Hi everyone, we are the group 10 and today we are going to talk about the finding the great circle distance, the initial course, the latitude of vertex, the final course, and the DLOV, which is important in this topic. So the members are the Cadet OSING, GILBERT, the Cadet Villarosa, and the Cadet VILLEGAS. So our course outcome is that we can demonstrate you on how to make the shortest navigable distance between the point of departure and the point of arrival. So our learning outcome for this topic or for this discussion is that at the end of the virtual session, students should be able to understand the following, such as finding the DLAT and DLO and solving the DLAT and DLO, and also solving for the great circle distance and solve for the initial course, solve for the latitude of the vertex or lat of vertex, and then solve the final course, and lastly solve the DLOV. So our question would be: a vessel from latitude 45 degrees and 17 minutes south and longitude 106 degrees 14 minutes west sailed to latitude 31 degrees to 22 minutes north and then longitude 138 degrees and 49 minutes west. So find the DLAT, the DLONG, the great circle distance, initial course angle, initial course true, and then latitude of vertex. And we have also to find the final course angle and final course true and DLOV. So the first thing that we're going to do is to discuss all about the latitude and how to find this. So our latitude 1 would be 45 degrees and then 17 minutes north. And then our latitude 2 would be 31 degrees and 22 minutes south. So basically, since it has different names, which is north and south, basically we will add this one. So if we add this, we will get 76 degrees and then 39 minutes. And for our names or our suffix for the DLAT, it depends, or it is on contrary, because basically in latitude 1 we started at north, and then in our latitude 2 we arrive at south. So basically our distance or our point is that we are going to south. So that's why our DLAT would be 76 degrees and then 39 minutes south. And then next one would be finding the longitude. So in longitude 1, we have 106 degrees and then 14 minutes west. And then our second longitude, which is longitude 2, is 138 degrees and then 49 minutes west. So basically, since it has the same name, so we will subtract it. So in subtracting it, since we know that latitude 1 is bigger or greater than latitude 2, then we will just subtract it using getting any minute, which is 1 minute is equal to 60 seconds. So basically we just have to borrow or else we just have to subtract it manually. So if we would subtract it manually, then we will get the DLO, which is the 032 degrees and then 35 minutes west. So why do we have west? So basically because if we're trying to analyze it furtherly or thoroughly, since we have our longitude 1 is 106 and then our latitude 2, longitude 2 is 138 degrees, then we will going to our right, which is the west. So basically our DLO sign would be west. So our answer would be 032 degrees and then 35 minutes west. Now we have to find the great circle distance or great circle sailing. So our formula for this would be cosine GCD or great circle distance equals to cosine DLO times cosine latitude 1 times cosine latitude 2 plus or minus sine latitude 1 times sine latitude 2. So in solving this, since our GCD is not identified yet, so we have to follow the formula. So cosine DLO, so our DLO would be 0.32 degrees and then 35 minutes. Then times to cosine lat1, which is 45 degrees and then 17 minutes, times cosine latitude 2, which is 31 degrees and then 22 minutes. And then next one would be, we would minus it, and then sine, which is latitude 1, 45 degrees and then 17 minutes, and then times to sine 31 degrees to 22 minutes. So if we would calculate it, if we would calculate it separately, so the first one would be 0.50622, and then the second one would be 0.36987. So basically, if you're wondering why is it minus, because we have different names. So since it has different names on our DLOs, so basically we will use different names. Subtraction, since we know that if it has the same name, then add, and then if it has the same name, then subtract, and then if haven't the same name, so then we will subtract. So next would be, if we will subtract it, then we will get 0.13635. So inverse to cosine, which is cosine negative 1, 0.136635, then we will get 82.16331. So if we would put our side, we would click our calculator into degrees, then we will get 82 degrees and 9.7 minutes. So basically we have to multiply it to 60 so that we could get the nautical miles, and then once we get it, that would be the answer for our great circle distance. So our answer for this one would be 4,929.4 nautical miles. So the next topic would be the initial course. So our initial course, we have this formula, which is cosine initial course equals sine latitude minus cosine GCD times or multiply to sine latitude 1 divided by or over sine GCD times cosine latitude 1. So since we already got those data that we have discussed earlier, so the next thing that we're going to do is to find our initial course by following the given formula that we have. So we have sine latitude 2, which is 31 degrees and 22 minutes. Subtract it to cosine 82 degrees 9.7, which is our GCD, and then multiply to sine 45 degrees 17 minutes, and then divide it to sine 82 degrees 9.7 minutes times cosine 45 degrees and then 17 minutes. So if we would calculate it separately, then we will get 0.42360, and for our denominator, then that would be 0.69703. So if we would divide 0.42360 over to 0.69703, then we will get the answer as 0.60772. So next thing that we will going to do is to inverse it. So cosine negative 1 is, and then compute 0.60772, type it on your calculator, then the result will be 52.57508. So basically we have seen that there is a prefix which is north, and then the suffix which is south. because basically if we're finding for initial course, the our prefix, which is north, is based on our latitude 1, and for our suffix, that would be longitude 1. So basically it is north and west. So after we get 52.57508, then we will click into our calculator into degrees, so that would be 54 degrees and then 34.5 minutes west. So, and getting the 305.4 degrees true, or which is the initial course true, since we already get the initial course angle. So, in getting the initial course true, we just have to use the 4 quadrants of finding the courses. So, if we are heading to north up until east or northeast, then that would be as is. And then if we're heading to east to south or south to east, then we would minus it or subtract it to 180. And then if we're heading to south to west or west to south, then we will add it to 180. And then if west to north or north to west, then we will subtract it to 360. So basically, since we have this northwest, so we have to subtract it to 360. So 360 minus 54 degrees and then 34.5 minutes, then we will get the 305.4 degrees true.
Good day everyone, I'm Villegas. So, in solving latitude of vertex, first, you must calculate cosine latitude vertex. Equals cosine latitude 1 times sine initial course equals cosine 45 degrees and 17 minutes times sine 54 degrees 34.5 minutes equals 0.70360 times 0.81487 equal 0.57334. You will inverse it, click shift in the calculator, then click cosine the encode 0.57334. Then you will get a result of 55.01654. After you get then answer, click shift or degrees in the calculator to get the final answer, which is 55 degrees 0.9 minutes north.
So our final course, in calculating our final course, we have this formula, which is cosine final course equals to sine latitude 1 minus cosine GCD times sine latitude 2 divided by or over to sine GCD times cosine latitude 2. So we already calculate or get the answers from the previous calculations, so we just have to follow the steps. So now we have the sine latitude 1, which is 45 degrees 17 minutes, minus the cosine GCD, which is 82 degrees 9.7 minutes, and then multiply to sine latitude 2, which is 31 degrees and 22 minutes. And then we will get the answer 0.16735, and then over to or divide it to sine 82 degrees, which is the GCD, so 82 degrees 9.7 minutes, and then times or multiply to cosine 31 degrees to 22 minutes. So we will get 0.84589. So if we would divide it, so then we will get 0.19784, and then same procedure, we have to inverse it. So cosine negative 1, 0.19784, then the answer would be 78.58932. So we have to click the degrees on our calculator, so we will get 78 degrees 35.3 minutes. So our suffix and prefix would be depends on the final course because it is on contrary. So our latitude 2 would be our prefix, and then how to determine our suffix is that we have to use the dilo, which is west. So we will get 258.6 degrees true by south to west. So since south to west, then that would be add to 180. So if you would add it, then we will get 258.6 degrees true.
In solving for the log, here is the solution. Cosine initial course over sine latitude of vertex is equal to cosine 54 degrees 35.5 minutes over 55 degrees 00.19 minutes. So if you will divide it, you will get 0.70748. Then after that, you inverse, pick shift, and sign that there would be a sign -1. And after that, encodes 0.70748. And after again, then inverse, then you will get 45.03025. Then click shift or degrees in your calculator, and you will get 45 degrees 0.01.8 minutes north.
So those are the things that we have learned upon our topics, and we hope that you have enlightened and you learned something from our discussion, which is all about finding or calculating the GCD initial course, the LAT vertex, the final course, the DLOV, and also the DLAT and DLOS. And we hope that you have gained some knowledge about what we have discussed upon from our example. So that would be all. Thank you.